Okay, I would like to put some more words about these slides, since some of you have questions about the homework. So let's see. In this digital light processing process, basically here is the lens, and an image will be projected through the lens to a plane, where the liquid resin is cured. For example, in this case, you have a projection plane over here, and the dimension of this, which is the image, the width of the image, can be calculated if you know this angle and this distance, which I've explained in the previous videos. But the thing you have to know is there could be different projection plan. Let's see, you just want to have a projected image to be here. Let's see here. That's the projection plane. And then the width is smaller. You can tell by knowing this distance and again this angle, right? You could compute this this width. And another thing is, no matter the image is projected on this plane or this plane, they all have the same pixel numbers. Let's say you have an image which has a resolution 1920 by 1080, right? That means no matter the image is this big or this big, in the x-axis, it has the same 1920 pixels, and in the y direction, I mean in the y-axis, it has 1080 pixels. But the size of the image are different. That means the distance between each of the pixel will be different, and how you can divide this 1920. I mean, you can divide the actual image size in millimeter by this 1920. Then you will have the distance between each of the pixel in millimeter, and or you have if the image is here. Let's see the image here with a different distance between the lens to the projection plane. Then you use the dimension in millimeter here and divide it by 1920, and then you will have the distance between each of the pixel on this projection plane. That's why there will be different resolutions or the feature size if you project the image onto different projection plane. And this distance between each of the pixel gives you the minimum 3D printed feature size. You can just think it intuitively. You have an image. If you with a fixed pixel count, and if you project it in an appropriate distance, you will see a clear image. But you further project it to a far plane, then you cannot see it clearly, because with the given pixel number, the distance between the pixel is very large, and you will not have a fine feature shown on that large image. So that's why this gives you the different 3D printed size. And I hope this will help you to understand the homework questions. Also, same thing happens to the y direction. You basically you just do the same thing to the x and the y independently. Okay.